This is the video for section 8.4 of your textbook on absolute value equations. And we're going to talk about the basics of absolute value equations. So let's let C be a positive number. And so just so that we're not working with a generic value C, let C equal something like 5. I want to talk about what it means for an expression like the absolute value of x to be less than or equal to 5. So you have to remember that the absolute value of x means the distance of x is from 0 on the number line. The distance x is from 0 on the number line. Oops. So this means that however far away x is from 0 on the number line, its distance is less than or equal to 5. So the distance between x and 0 on the number line is less than or equal to 5. So what we're really talking about is a range of values, and we can only range so far in each direction. So let's talk about this on the number line. Let's do it visually. Here's positive infinity, here's negative infinity, and we don't want to focus on the number 5 just yet. We want to talk about the number 0. And wherever x is, let's say x is somewhere on the number line. I don't know where x is, but it's somewhere between a range of positive 5 to the right and negative 5 to the left. That is to say, we can go out as far as 1, 2, 3, 4, 5 units to the right, including 5 units. Or we can go 1, 2, 3, 4, 5 units to the left, including 5 units. And so when you have the absolute value of something less than or equal to a positive number, I like to think about this as kind of like a leash, right? You have a, I don't know if I can draw this really well here. A little Scottish Terrier here. You know what I'm talking about? Little tiny hairy dogs with a mustache. And he's got a leash on, and he's staked at 0. And he can go up to and range a distance of 5 units in either direction. So if the absolute value of x equals 5, then x can be equal to plus or minus 5. And that's as far as the dog can sort of range in either direction. X equals 5, x equals negative 5. But you don't have to use up all of that leash. If we're talking about the absolute value of x being less than or equal to 5, then it turns out that x can actually be anywhere between negative 5 and 5. And this is how we write that. Or as an interval between negative 5 and 5 with those closed brackets, because we're talking about specifically it being less than or equal to, right? We have those equals signs there. So in general, when you have the absolute value of an expression, however complicated it is less than or equal to a number c, where c is a positive number, then this can be rewritten. And in fact, you should rewrite it as negative c is less than or equal to whatever that expression is less than or equal to positive c. Or just c, I should say. I shouldn't even say positive c, because we already know that c is a positive number. So that's going to give us this triple inequality that we have learned to solve previously. The other way to look at this is equivalently, we can take the absolute value of an expression less than or equal to c is the same as the compound inequality the expression is less than or equal to positive c, and the expression is greater than or equal to negative c. If you want to talk about the term and unions and intersection, either way, it's going to give you the exact same result here. So let's take a look at a simple example of that. Example number 1. The absolute value of 3x plus 2 is less than or equal to 7. So what we want to identify here is the fact that this is a less than or equal to symbol, which means we can break this up as 3x plus 2 without the absolute values is still less than or equal to 7, but it's also simultaneously greater than or equal to negative 7. So this is as a triple inequality. And then you can solve it. So let's see, we'll subtract 2 from all 3 sides, and we'll get negative 7 is less than or equal to 3x is less than or equal to 5. And then we'll divide all 3 sides by 3, and we'll be left with the inequality. Oops, this isn't a negative 7. This is a negative 9. My bad. Whoopsie, negative 9. And this gives us negative 3 is less than or equal to x is less than or equal to 5/3. We've got a fraction on the right there. That's kind of the best we can do. Or we could actually rewrite that as the interval negative 3 up to and including 5/3, also including negative 3. And that would be our answer. Alternatively, we can take the absolute value of 3x plus 2 is less than or equal to 7, and we can break this up into 2 possibilities joined by the and statement. Either we just drop the absolute values because the inside of this is positive. Either the absolute value of, so either 3x plus 2 is less than or equal to 7, and 3x plus 2 is greater than or equal to negative 7. So remember that when we multiply by a negative or divide by a negative, we have to flip our inequality. So you'll notice that I've flipped the sign on 7, and I've also flipped the inequality. So this is flip both sign and inequality on this version. And then you just solve them both separately, right? We'll subtract 2 from both sides. We'll get 3x is less than or equal to 5, and 3x is greater than or equal to negative 9. We'll divide both sides by 3. Remember, I'm just doing the same problem again, so if you're thinking like, oh wow, he's getting the same answer, that's kind of the idea here. So x is less than or equal to 5/3, and x is greater than or equal to negative 3. And then if you draw that on the number line, right? Here's negative infinity, here's positive infinity. And let's see, negative 3 is a negative number. We'll put that on the left. And then 5/3 is a positive number, so that's going to be on the right somewhere. And this inequality says that we have to be equal to or less than 5/3. And this inequality, that's not a good color. This inequality says that we have to be equal to, solid dot, or greater than negative 3. And because this is an and statement, we want the intersection between these two, which means we want where they overlap, which is this region in the middle here, and we can rewrite that as the interval negative 3 up to 5/3, including both negative 3 and 5/3 because of the fact that it isn't closed dot, technically, on both of those values in both of those inequalities. So there's our answer, thinking about it in terms of an and or an or statement. In this case, an and statement or intersection. Now, I should say that this is exactly the same technique had this been a different inequality, had this been or less than. The only difference is I wouldn't have included my endpoint, so let's do that example. Example number 2, 2x plus 5 in absolute value minus 3 is less than 10, let's say. Now in this case, I don't have the absolute value isolated first, so let's isolate the absolute value of the expression first. So what will that look like? Well, we will add 3 to both sides here, and we'll get the absolute value of 2x plus 5 is less than 13. And I guess I'll just use one technique here. I won't do this one 2 different ways. We'll use the triple inequality because this is less than, because it's pointing to the left with the absolute value on the left. That allows us to break this up as 2x plus 5 without the absolute value is less than 13, but it's also greater than negative 13. And so now we can subtract 5 from both sides. And we're going to get negative 18 is less than 2x is less than 8. We'll divide both sides by 2. Sorry, not both sides, all 3 sides by 2. And we'll get negative 9 is less than x is less than 4. And that is the same thing as the interval negative 9 up to 4, but not including negative 9 and 4. So there's our answer as an interval. All right. There it is.